Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Welcome everyone. So tonight we delve into the challenges of evaluating LM output. We'll explore advanced metrics like the LLM-as-a-judge approach and tools like DeepEval, emphasizing how careful metric selection is crucial for comprehensive assessments and responsible AI. What are the key challenges faced in evaluating the outputs of large language models, and how do traditional metrics fall short in addressing these challenges?
Evaluating the outputs of large language models learns is just like trying to judge a painting without really understanding art. You want to see if it's beautiful or meaningful, but traditional methods often miss the finer details that make a piece really special. One of the key challenges is that LM outputs can be really complex and nuanced, much like poetry or stories. Traditional metrics like BLEU or ROUGE are like using a ruler to measure a painting's beauty. Focus on simple matches of words or phrases, but ignore the deeper meaning or context. So this means they can miss important aspects of the LLM's output, such as creativity or emotional resonance. Another challenge is that the choice of evaluation metrics can vary greatly, so depending on the specific application of the LLM. For example, a chatbot designed for customer support might need to be evaluated differently than a model used for writing assistant sites. This means a one-size-fits-all approach rarely works. A more reliable method is using LLMs themselves as judges, which is like asking an experienced artist to critique a painting. This method uses natural language rubrics to assess the outputs, but it requires various techniques to ensure accuracy, such as eval. So in summary, the challenges in evaluating LM outputs stem from their complexity and the limitations of traditional metrics, which often fail to capture the richness and context of the generated text.
Could you elaborate on the concept of LLM-as-a-judge methods and how they improve upon traditional evaluation metrics in assessing the quality of LM outputs?
The concept of LLM-as-a-judge methods is basically like having a wise friend review your homework instead of just checking if you spelled words correctly. This friend understands the subject and can give feedback on how well you explained your ideas. So these methods use LLMs themselves to evaluate the quality of outputs. So employing natural language rubrics that consider various important aspects like correctness and relevance. This kind of approach improves upon traditional evaluation metrics, which often miss the deeper meanings and nuances in the text, so much like a simple spell checker can miss the essence of a story. However, while LLM-as-a-judge methods such as DeepEval can provide more accurate assessments, they still face challenges just like asking a friend to review your work might lead to varying opinions. These methods can sometimes be inconsistent. So this inconsistency is a drawback, as it means the evaluation might not always be reliable. In summary, LLM-as-a-judge methods enhance the evaluation process by using the reasoning capabilities of LLMs to provide more comprehensive feedback. However, users actually need to be cautious about the potential for variability in the results.
What are some of the essential metrics highlighted in the study for evaluating LM outputs, and how do they contribute to a more nuanced understanding of the model's performance?
Some essential metrics for evaluating LM outputs include answer correctness, semantic similarity, and hallucination. Answer correctness is just like checking if a math problem was solved accurately. It ensures that the information provided by the LM is factually correct and meets the expectations of the user. Semantic similarity measures how closely the meaning of the LM's output matches the intended message, much like just comparing two different ways of saying the same thing. This helps in understanding if the LM is capturing the essence of the query or task appropriately. Hallucination refers to instances where the LM reads information that is false or fabricated, similar to telling a story that sounds so convincing but is entirely made up. This metric is crucial as it helps identify when the model strays from reality, ensuring that users can actually trust the information it provides. These metrics contribute to a more nuanced understanding of the model's performance just by examining different dimensions of its output, depending on the specific use case, like whether it's a chatbot or a writing assistant. Different metrics can be prioritized to actually get a clearer picture of how well the LM is functioning and where improvements are actually needed.
Can you discuss the significance of contextual relevancy and responsible AI metrics such as bias and toxicity? In the evaluation framework for LLMs. How do these metrics enhance the overall assessment of a model's output?
Contextual relevancy and responsible AI metrics such as bias and toxicity play a vital role in evaluating LM outputs much like checking the ingredients in a recipe to ensure a dish is so healthy and safe to eat. Contextual relevancy ensures that the LLM's responses are appropriate and aligned with the specific situation or query. So it's like making sure a chef uses the right spices for a particular cuisine if the context is off, so the final dish won't taste right. This metric helps in fine-tuning the model to provide answers that make sense in the given context, enhancing user satisfaction and trust. So, responsible AI metrics, including bias and toxicity, are absolutely essential for ensuring that the outputs of LLMs do not contain harmful or offensive content. The bias metric checks for unfairness in the model's responses, such as political, gender, or social biases. This is crucial in applications where decisions are made based on the model's outputs, like loan approvals or like hiring processes. If the model shows bias, it could lead to unfair treatment of individuals based on characteristics like gender, ethnicity, which is like serving a dish that is only suitable for some and harmful to others. The toxicity metric evaluates whether the generated content is offensive or harmful, similar to ensuring that food is safe for everyone to eat. This helps in maintaining a respectful and inclusive environment, particularly in applications like chatbots or social media interactions. By incorporating these metrics into the evaluation framework, developers can enhance the overall assessment of a model's outputs. They ensure that the LLM not only provides accurate and relevant information, but also does so in a way that is so ethical and responsible, ultimately leading to a more trustworthy and user-friendly AI experience.
So how does the open source framework DeepEval support the implementation of these evaluation techniques, and what advantages does it offer to developers and researchers working with LLMs?
The open source framework DeepEval supports the implementation of evaluation techniques by providing a flexible study that really integrates methods like GEVAL. This is akin to having a versatile toolbox that allows developers and researchers to choose the right tools for their specific needs when working with large language models like LLMs. DeepEval offers several advantages. 1. Regression testing. Developers can test and evaluate their LLM applications over time to ensure that updates do not introduce new issues. So this is like checking a car's performance regularly to ensure it runs so smoothly after repairs. 2. A/B testing. The framework allows for a really easy comparison of different prompts and models. It's like tasting, like two different recipes side by side to see which one is better. 3. So cloud-based management users can edit and manage datasets online, making it convenient to access and modify information from anywhere, similar to having a digital recipe book that you can update on the go, sort of. 4. Observability. DeepEval provides tools for monitoring LLM performance in real time, which helps researchers see how their models are performing as they interact with users like FAQ. This is like having a dashboard in a car that really shows how fast you're going, and if there are any issues. 5. Publicly shareable reports. Users can share their testing results with others, like easily, promoting collaboration and transparency in research. It's like sharing your cooking results with friends so they can learn from your experience. 6. Automated human feedback collection. This feature allows for gathering feedback from users automatically, so helping to refine the model based on real-world interactions. It's just like getting instant reviews after serving a meal to guests. Overall, DeepEval enhances the evaluation process by providing a comprehensive, user-friendly study that supports various testing and evaluation needs, so making it easier for developers and researchers to ensure the quality and effectiveness of their LLM application.
What considerations should developers just keep in mind when choosing between generic and custom task-specific metrics for their LLM application? How do these choices actually impact the evaluation outcome?
When choosing between generic and custom task-specific metrics for LLM applications, developers should consider a few key factors like 1, use case alignment. Custom metrics are designed to evaluate specific tasks, ensuring that the evaluation criteria directly reflect the goals of the application. So, for instance, if the LLM is really meant to summarize news studies, a custom metric that assesses summarization quality will be essential. This is like having a specialized tool for a specific job isn't the right tool. Makes the task easier and more effective. 2, system architecture generic metrics. So, on the other hand, are broader and can apply to various applications. They typically focus on fundamental aspects like faithfulness or task completion. So, while these metrics are useful, they may not capture the unique requirements of a specific use case. It's like using a general purpose tool that might work but doesn't fit perfectly for the task at hand. Like 3, balanced developers should aim to include at least one custom task-specific metric alongside a few generic metrics. So this balance ensures that the evaluation pipeline is robust and tailored to the application while still covering essential performance aspects. So it's like having a well-rounded toolbox that includes both specialized and general tools for different tasks. 4, consistency. If the LLM system changes, the custom metrics should remain relevant and not just require redefinition. So this consistency helps maintain a stable evaluation framework over time, making it easier to track performance across different iterations of the application. The choices made regarding metrics directly impact the evaluation outcomes. Using the right combination of metrics ensures that the evaluation accurately reflects the model's performance in real-world scenarios. If developers rely solely on generic metrics, they may overlook critical aspects of the models like effectiveness, leading to misleading conclusions. Conversely, a well-designed set of metrics can provide valuable insights into how well the LLM really meets its intended goals and where improvements are needed.
Well, that really brings us to the end of a truly insightful discussion. Just a huge thank you to our audience for joining us today. We've delved deep into the complexities of evaluating large language model outputs, understanding why traditional metrics often fall so short, and capturing the nuances of creativity and emotional depth. So we explored the innovative LLM-as-a-judge approach, leveraging LLMs themselves to assess quality through natural language rubrics, while also acknowledging the potential for variability in its results. Our conversation highlighted essential metrics like answer correctness, like semantic similarity, and the critical issue of hallucination, all of which are vital for a clear picture of an LLM's performance. We also emphasized the non-negotiable importance of contextual relevancy and responsible AI metrics, such as bias and toxicity, to ensure ethical and appropriate outputs. For those looking to implement these techniques, we learned about the open source framework like DeepEval and its advantages, including regression testing, A/B testing, and real-time performance monitoring. Ultimately, the takeaway is clear: developers must carefully balance generic and custom task-specific metrics to achieve so comprehensive and relevant assessments. It's this careful metric selection that directly influences the effectiveness of the sort of evaluation process and the insights we gain into an LLM's true capabilities. So thank you once again for tuning in. So we look forward to seeing you next time.